We're going to find the potential and the current for each resistor in this circuit. I've redrawn the circuit here so that you can see it more clearly. Perhaps you want to pause it and copy it down quickly here. Okay, so to begin with, this looks like a real complicated mess. The first thing I'm going to do is I'm going to redraw the circuit. I'm really going to make no changes to the circuit's topology. That is, everything that was connected will still be connected in exactly the same spot. The circuit will behave the same way, but it'll be easier for us to look at and analyze. So I'm going to draw the voltage on the left, the power supply I should say. So here's our battery. We've got a 12 volt battery and it's going top to bottom just as it was in the original circuit. Everywhere along this line is 12 volts. Everywhere along this line is 0 volts. Now I'm going to draw in R1, followed by two branches. One contains R5 and R4. The other contains R2 and R3. Finally, we have R6. Okay, now if you take a close look at what is connected and where in this circuit, you will see that it's identical to this one. However, when you draw it out this way, it becomes more apparent. The relationship between the voltage here, that is the electrical potential here, and the electrical potential here. That is, from here to here is 12 volts. So by Kirchhoff's voltage law, any path from here to here is 12 volts. So from here to here is 12 volts. Also from here to here, plus this, plus that will give us 12 volts. So the voltage across R1 plus R3 plus R4 plus R6, sorry, that's R5. R1 plus R5 plus R4 plus R6, that voltage is equal to 12. Likewise, R1 plus R2 plus R3 plus R6 is also equal to 12. Because we're solving several things here, I'm going to start out by getting organized. And I'll make a table. I have 6 resistors to deal with. And I'm interested in their resistance, their potential, and their current. So as I find components here, I'm going to put them in the table. To start off with, I have all these values. R1 is 5 kiloohms. R2 is 4 kiloohms. Okay. And at the start, I don't know any of the voltages, that is the potentials, and I don't know the current anywhere. So when we look here, there's really two ways forward. We could make equations that model everything that's going on in here and solve simultaneous equations with several unknowns. I prefer to draw simpler and simpler circuits, learn something from them, and then take that information back to our original circuit. So the first simplification I'm going to do is I'm going to combine R5 and R4. They're in series, so I can simply add them. And I'm going to combine R2 and R3. They're in series, so I can add them as well. You can think of this like following bedmas, where you start inside brackets and work your way out. R5 is in a sense parallel to R2, but it's not directly parallel because even though one end of the resistors are connected, the other end of those resistors are not directly connected. So I can't combine R5 and R2 as if they're truly in parallel. However, R5 and R4 are truly in series. R2 and R3 are also truly in series. So I have 12 volts, R1, RA, RB, and R6. Where RA takes the place of R5 and R4. So RA is R5 plus R4. RB is R2 plus R3. That makes them both 7 kiloohms. As R2 was 4 kiloohms and R3 was 3 kiloohms, and R5 was 3 kiloohms and R4 was 4 kiloohms. So I'm adding them together to give me 7 beside 7. My next step in simplifying is I'm going to combine these two imaginary resistors, RA and RB, are indeed in parallel because one end is connected together and the other end is directly connected together. So I'll combine them to make another equivalent circuit where I still have R1 here. I'm going to call this RC. Doesn't matter what I call it, I just have to make up a name that's not already in use. And the value of RC is going to be RA parallel to RB, which is 7 kiloohms parallel to 7 kiloohms, which is 3.5 kiloohms. If you're not sure why that's 3.5, I can do a quick aside here. RA parallel to RB is equal to RA times RB over RA plus RB. If you use Ohm's law and a little bit of algebra, that formula readily appears. 7 times 7 is 49, 7 plus 7 is 14. And when you divide this out, you'll get 3.5. A neat shortcut is if RA and RB happen to be identical, the result is going to be half of one of them. That's how we can quickly go from 7 to 3.5. Okay, so R1 is still 5 kiloohms as it was in the beginning, and R6 is 1 kiloohm.